Flack math! Give me some math and I'll give you some flack. Flack math!
Actually solving equations in a more algebraic concept. So, lesson 23. We're going to talk about equivalent, not fractions, but equivalent equations. You guys remember the golden rule for equivalent fractions? If you want to make an equivalent fraction, what's the one thing you have to remember?
Do to the top what you do to the bottom.
Yeah, so it's like the golden rule, right? Whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. You can, but it's only restricted to multiplication and division. So you can't, like, say 3/4. If you add 1 to both the top and the bottom, that doesn't work, right? But multiplication does. 3/4 times 2 times 2, 6/8. That works. Or division works too. I could say 1.5 over 2, and that's the same fraction as 3/4. It's equivalent. So you can do whatever you want, multiply or divide whatever you want to the top, as long as you do the same thing to the bottom. Well, an equation is just like an equivalent fraction, except it's tipped over, so it's sideways, and it's not restricted to multiplication and division. Okay, so you can do whatever you want to the left side as long as you do it to the right side. Or you can do whatever you want to the right side as long as you do it to the left side. You can add, subtract, multiply, divide, square root. You can flip it upside down as long as you flip the other side upside down. You can do a lot of stuff, okay? So let's write some equivalent equations. X plus 6 equals 9. X plus 10 equals 13. So do you guys see why these are equivalent equations? Can you tell what we did to the top equation, what we did to both sides? What did we do to both sides? We added something, right? We added 4 to both sides and it works. The other way you can tell it's an equivalent equation, yes?
It's 3. Both sides.
Why do you think it's 3?
6 plus 9. Wait, 6 plus 3 equals 9. 10 plus 3 equals 9.
Oh, x equals 3. Yeah, but we didn't add 3 to both sides. We added 4. So if you add 4 to both sides, you get this equation. X plus 10 equals 13. So see, whatever we did to both sides. The other way you can tell it's an equivalent equation, though, is if the x value is the same. Okay? So if x equals 3 in both equations, then it's an equivalent equation. You can make this look just like this. All right? Here's another equivalent equation. Okay, this is an equivalent equation. Now, I don't know what happened or how I got to here, but I do know that if x equals 3, then this equation is true, right? So these are equivalent equations. I guess I could have subtracted something, or multiplied by 5, and then subtract 16 from both sides, or something, or not 16, but what is it? Like 34 from both sides, and you get this type of thing. Okay, so that you can get there from here, but you don't need to know how to do that. But as long as you know that the x values are the same, then they're equivalent equations. Okay. All right. So looking back at this first one, if you leave something out too long, it eventually gets taken. Bummer. An eraser now. Okay, so we're going to talk about the addition property of equality. So the addition property of equality says you can add the same thing to both sides and it doesn't change the value of the x or the variable. It doesn't change the value of the equation. So just like equivalent fractions, 3/4 and 6/8, the value is still the same. It just has more parts. It just looks different, but it's still, the value is still the same. So addition property of equality. If A equals B, then A plus another number equals B plus that same number. So see how I'm adding the same thing to both sides of this equation? So a lot of people look at it like this, where you got the tracks here, railroad tracks, and then you can do whatever you want on one side of the tracks as long as you do it to the other. Otherwise, you'll get sued because you're not being fair. Not really. Mathematically sued, I guess. All right. Good. So that's the addition property of equality. That means you can add whatever you want. You can add fractions to both sides. You can add negative numbers to both sides, which brings us to our next property of equality, is the subtraction property of equality, right? Because adding a negative is the same thing as subtracting, right? So you can subtract whatever you want from both sides and it's still an equivalent equation. Okay, so we use this a lot to solve equations. So your main goal, and this is in equations, there are three principles. Of solving equations. You've got a main goal. Number one, your main goal is to get variable by itself. You guys heard that before? Okay? So your main goal in solving equations is to get the variable by itself. You're trying to isolate the variable, okay? Now most of you can look at this equation and say 3, okay? And your brain automatically just wants to figure out what the unknown is. That's why most of you said 3, okay? That's great. But it's not always going to be that easy. I mean, that was a pretty easy one to solve. Pretty easy x to find. Number 2 is to get rid of stuff, to eliminate things, because that's your goal. Your goal is to get the variable by itself. So you have to eliminate stuff on that side. So to eliminate stuff, you need to perform the opposite operation. Okay, and then the golden rule. You can eliminate stuff all day long as you do the same exact thing to the other side. If you want to get rid of something on the left side, get rid of it. But get rid of the same amount of weight or add the same amount of weight or do whatever you just did to the left side to the right side. Okay? So whatever you do to one side, do to the other. Okay? So I wrote those over there just because I want to keep those there. But number 1, main goal, get the variable by itself. Number 2, to eliminate stuff, because that's what you need to do to accomplish your goal, do the opposite operation. So if something's being added to x, what are you going to do? Subtract it. If something's being squared, then what do you do to get it by itself? You not divide. Remember we talked about this. What's the opposite of squaring something? Square root, that's right. So if it's x squared equals 9, how do you get that x by itself? You square root x squared, and that gets rid of the little 2, right? And then number 3, the golden rule. So you can eliminate whatever you want, but whatever you do to one side, you have to do to the other, okay? All right, so this is the addition property of equality. I'm going to show you, just give you a couple examples, and then we'll move on to lesson 24. Example 1, solve this equation. Now, I know that you know that I know that this is 15, right? Because you see that, and probably within 5 seconds you can tell it's 15. But I want you to solve this algebraically. So your main goal is to get x by itself. So you have to get rid of something, right? What do you have to get rid of?
3.
The 3. And what operation is happening to that 3? Subtraction. So what's the opposite of subtraction?
Addition.
Addition. So here's how I want you to do this. And this and Audrey and I will be so grateful if you do this. Write it out. Whatever you do to one side, do to the other. If you accidentally bump your left shoulder, just give your right shoulder a little bump, okay? You'll thank us later, okay? But see how it looks even? See, if this was a scale, then I feel good about that. If I just put +3 there, or +3 there, and because I know I'm going to cancel that, yeah, I mean, you'll still get x equals 15, but this feels better, looks better, and when you go back and look at your work, it'll look good, better, but you'll be able to understand what you did, okay? Yes, Nathan.
Go to the restroom.
Yes. Okay, so that's all we did. So to get rid of that 3, which was being subtracted, we had to add it. But you can't just go around adding 3's to things. That would be nice. Whatever you do to one side, do to the other. Be fair. Be just. Okay, good. All right, let's do another one. Ready? X plus 1/4, you fractioned it, equals -3/8. Okay? So this one, maybe you can't do in 5 seconds, right? So, follow these rules. See if you can do that one on paper.
I do not remember how to do that.
So, just follow those steps. You can do it. The only reason you can't is if you choose not to. But you can do it. Main goal is to get variable by itself. Is x by itself on that left side? No. So you have to eliminate something. How do you eliminate that 1/4? The what?
Subtract.
Yeah, so what's being done with that 1/4? Addition. So to get rid of it, you do the opposite of addition, which is subtract. So you're going to subtract 1/4 from both sides, because whatever you do to one side, you have to do to the other. You can't just go around subtracting 1/4. Yes. Oh. Other Mr. Flack. Okay. So far so good? Was that doable? Yes. Uh-huh. Okay. So this, you get to have this satisfying experience. When you subtract 1/4 after it's being added, you cross it out. Okay. That helps you, believe it or not, it's not just for Audrey and myself, but believe it or not, this helps you understand the process. Because that's the goal, is to get rid of it. Right? And now, the only thing on the left side is the x. And the only thing on the right side is a quick little math problem, and you're done. Okay? So see how the equation is still balanced. We got rid of 1/4 of a pound or whatever you want to call it. But now when you just get rid of 1/4 on this side, it's not balanced. So you have to get rid of 1/4 on the other side too. And now it's balanced. Okay? So let's do this math. How do you add fractions?
You turn. You just common denominator.
Right. Common denominator is 2/8, right? So and now we're good.
What about
Okay.
the negative sign?
All right. What about the negative sign? It's basically -3/8 minus 2/8. Well, what is that? Well, let's get rid of the fractions for a second. Let's say it's -3 minus 2. What's -3 minus 2?
-3 plus -2.
Right. So what's -3 plus a couple more negatives?
Another negative.
-5/8. Okay. So fractions complicate things, right? It doesn't matter how easy the fractions are, fractions, decimals, percents, even though you may understand fractions, decimals, and percents, as soon as you throw them into some other mathematical concept, it just confuses you. All right? It just adds a level of confusion. So try it without the fractions. So if it's -3 minus -2 or -2, that's okay. I'm subtracting with negatives. That's already confusing, but now I'm subtracting with negative fractions. That's really confusing. So write it out. That's what Zan did. He said, okay, this is -3/8 plus -2/8. Okay, well that's doable. You're adding two negatives together, so it's going to be more negative, right? Cool. All right, try this one on your own. Last example, and we'll move on. Example 3. K plus 2 1/3 equals 2/9. Try it on your paper. Everybody tries it. Now we had problems like this in pre-algebra, but it was based on that rule of, well, when you're missing an addend in an addition problem, you just take the answer and you subtract. Yeah, but now we're doing it algebraically, which once you get used to this process, you can literally shut your brain off and not have to worry about, okay, I'm missing what, okay, is it the minuend or the subtrahend? No, you don't have to worry about any of that anymore, ever. Okay, when you're doing algebra, you can turn your brain off in that area and just solve the equation. And solving equations is going to be like second nature to you, a lot of muscle memory stuff. You don't have to stress about it. Okay, what'd you do first? Somebody tell me what you did first.
Two and 1/3 minus 2 and 1/3. So that's
okay. Minus 2 and 1/3. And then over here,
minus 2 and 1/3.
minus 2 and 1/3. Good. So that's done. You don't have to worry about the left side anymore. Now you're just left with that nice little K on the left side. You only had one thing to get rid of and you did it. But whenever you do something, there's consequences. So now we have to figure this out. So what's 2/9 minus 2 and 1/3? So what do we do there?
Turn it into a mixed number.
Okay, yeah, we could start with that. I always like mixed numbers. So now it's 2/9 minus 7/3. Okay, that's good. That's a good step. I like that. What's next?
Common denominator.
What's the common denominator? 9. So multiply both the top and the bottom by 3, right? So now it's negative 21/9. Okay. So now we have 2/9 minus 21/9. Why is that confusing? Why is that difficult?
Because it goes into negatives.
Yeah, because it's a smaller number minus a big number. But when subtraction is confusing, what do?
Just add.
Yeah, chicken scratch. Turn it to addition. Bonk, bonk. Okay, now we've got a negative 29/9 on the battlefield with a positive 2/9. So what are they going to do? Are they going to join forces or are they going to fight?
Smash.
They're going to smash. All right, who's going to win? The negative, right? Because their 21/9 is more than 2/9. Okay, so how do you do this problem? People are going to die on the battlefield. That means subtraction. Okay, so now you got 21. What do? 21/9? Subtract, right? 2/9, and you end up with what? Anybody have an answer?
Negative 19/9.
Negative 19/9. You can leave it like that, because in algebra, we are a big fan of improper fractions. And you can change it if you want, negative 2 and 1/9, right? Either one works for me. Okay, so if this was this problem, k plus 3 equals 2, that's a different problem, right? How do you get k by itself? What do? Subtract 3 from both sides. 2 minus 3 is negative 1. Okay? See how much easier that is? But it's this. We just did the same steps, but what made it more complicated? What made this more complicated? This is the same equation. They're freaking fractions is what made it complicated. Okay? So but here's the deal. You've all shown me on your previous tests that you know how to add and subtract fractions. It's more work and more detail, possibly more mistakes, but you know how to do it. Okay? So follow the same steps. The rules don't change. The 3 principles don't change when there's fractions involved. It's still the same rules. Okay? Does this feel all right? Doable? Okay. Get into the habit of writing it out like this. Minus 2 1/3, minus 2 1/3. Cross it out. You'll thank me later. All right.
Flack math. Give me some math and I'll give you some flack. Flack math.